solve the problem. These are the basic formulas. You will have to remember it. First, the vector equation of a plane passing through a given point with a position vector, vector A, and perpendicular to a given vector, vector N, is vector R minus vector A dot vector N is equal to 0. If this plane passes from origin, then vector R dot vector N is equal to 0. Here, vector A is equal to 0 in condition when it passes from origin. An equation of a plane when it passes from a given point whose position vector is A and this plane is normal to vector N. Equation is vector R minus vector A dot vector N is equal to 0. If this plane passes from origin, equation is vector R dot vector N is equal to 0. It is very important to solve the problem. Its Cartesian form. The Cartesian equation of a plane passing through a point A, whose coordinate is here x1, y1, z1. Here its vector, position vector is A. Here coordinate is vector A1, x1, y1, z1. And perpendicular to a line having direction ratios n1, n2, n3. Here perpendicular to a given vector n. Here direction ratio is n1, n2, n3. It is Cartesian form. Direction ratio given. Coordinate of point A is given. Then the Cartesian equation of that plane is x minus x1 into n1 plus y minus y1 into n2 plus z minus z1 into n3 is equal to 0. Next, very important, the vector equation of a plane passing through a given point with position vector A and parallel to two given vectors, vector A and vector C, vector B and vector C. The vector equation of a plane which passes through a given point whose position vector is vector A and parallel to two given vectors, vector B and vector C, is vector R minus vector A dot vector B cross vector C is equal to 0. Now it's Cartesian equation. The equation of a plane passing through a given point A, x1, y1, z1. Here, the passing through a given point with position vector, vector A. Here, passing through a given point having coordinate x1, y1, z1. It is Cartesian equation. And parallel to two given lines having direction ratios b1, b2, b3 and c1, c2, c3. Here passing through a given point having position vector A and parallel to given vectors having vector B and vector C. Here parallel to two given lines with direction ratio b1, b2, b3 and c1, c2, c3 is x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 determinant that is equal to 0. Determinant that is equal to 0. It is Cartesian equation. Now next, very important, you will have to solve most of the problems with these equations. The vector equation of a plane passing through three non-collinear points, 3 points which are not collinear, three non-collinear points with the position vector ABC is the vector equation of a plane passing through three non-collinear points with the position vector A, B, and C. 3 points whose position vectors are A, B, and C respectively. We have to find the vector equation of that plane. That is vector R minus vector A dot vector B minus vector A cross vector C minus vector A, that is equal to 0. It is very important. Now it's Cartesian equation. Cartesian equation is here. The equation of a plane passing through three non-collinear points A, B, and C, whose coordinates are x1, y1, z1, x2, y2, z2, and x3, y3, z3 respectively. Coordinate of A, x1, y1, z1, coordinate of B, x2, y2, z2, and coordinate of C, x3, y3, z3. Then the equation of a plane in Cartesian form is determinant x minus x1, y minus y1, z minus z1, x minus x2, y minus y2, z minus z2, x minus x3, y minus y3, z minus z3, it is equal to 0. Determinant's value is 0. It is the equation of a plane passing through three non-collinear points whose coordinates are given.